but I got so many emails about people going home. I got really worried because my plan for today is to basically go over the review for the exam. So what I'm going to do is I'm going to share my screen. I'm going to step through. I put together a summary with everything that we've covered so far in this unit, and we can just step through it together. There's enough people here, like maybe few enough people here that I hope that y'all like just unmute and ask a question. I can just go point by point through this Jupyter notebook, but it's way more valuable for y'all to stop me if there's stuff that wasn't clear. And there's few enough people here that we could do this just like a glorified office hours, if that's all right. So before I take it away, does anybody have any questions about anything? No. Everybody's got all their stuff for the project. Okay, so on Monday after the break, we'll have a review. I'm going to treat that as just like open-ended questions anybody has, but I'm going to give that time for everybody to get started working on their final projects. There's going to be, I think, 3 lectures that will be able to help get you online. So if you have your stuff and hopefully you've started playing with it a little bit, come on in and me and Ben will be there and we'll be happy to get you started if you're having difficulty launching. And then the Wednesday after we come back, we're going to take this exam in class. Okay, but this is going to be the end of the material for the course. Okay, so what I've put together here is, I literally just went through, you can see it to the side. I went through all of the Jupyter notebooks that we've done so far. I've just pulled together all of the material that I want to make sure that you pay close attention to. So there are 5 lectures that are going to be on this exam. And some of this, it's not super amenable to taking exam, right? Like I can't really give you an exam on vibe coding, but I am trying to gather together representative questions that you can anticipate to ask, right? So just to bring this all in, right? This is the 3rd exam. The first exam, we really covered our Python fundamentals. The second part, we showed that we could apply those fundamentals to solve an ODE to make basic microcontroller stuff go. And really what we're doing in this 3rd unit is we hopefully got the confidence that we know enough basics that we can actually use, like I call it a big kid Python library, but the kind of library that if you get an internship or a job doing programming, you're going to be you will be expected to use something like this, right? So you may not want to do machine learning, you may not care about all this stuff, but at a minimum you're going to know the basics. You're going to be technologically literate, and if it comes down to it, you'll be able to make this go if you have to for work. Okay, so what I'm going to do is I'm going to go through each exercise, and I'm just going to answer them myself. If you want me to slow down or clarify anything, just unmute and say so. But otherwise, I'm going to go through it at maybe a bit of a brisk pace, so that way we can get through this quickly. The one thing I want to warn people, and I'm still not crazy about this, but because we've opened Pandora's box with the vibe coding, there's just a reality that tons of people in the class are now not learning anything more, right? And you're really just having AI do your homework for you and so on, right? As encouraged, right? Like that was the part of the section in the class. But just be careful as you're preparing for this class. Make sure that each one of these exercises you could, when you're studying, maybe print these exercises out and try to answer them on pencil and paper. That could be a way to prepare yourself, so that way you're completely removing AI from the loop. The last thing before I get going, I put in, this reminded me, there was a survey that I didn't get many responses from, but I am really curious about how everyone's feeling about all the AI stuff and whether this is something that we should include again next year. So I'm putting the link in the chat to this brief survey and whether you have any feedback you want. Okay, so let's get back to this. Okay, so for lecture 20, when we talked about how to use Gemini and so on, like I said, there's not much we can do in the exam to cover that. But I do want to make sure that you've pulled away an example of tasks where you feel like, you should have a good sense of where it's safe to use the large language models and where not. Okay, so we stepped through a few use cases where it's very clear, just you try it out and it does a good job. So if you ask it to make plots for you, if you give it some code that somebody's written and you ask it to explain how that code works, if you use, if you're using a library and you want an example of what function is in this library that I can use and what's the expected syntax and usage for that, that's the kind of place where it'll be helpful. I tried to curate a few scenarios where it will sort of fail spectacularly. And particularly, I want to press upon everyone that once you are a honest to goodness professional engineer, you're legally responsible for the code you generate in the same way that a doctor can get sued for malpractice, right? An engineer can get sued for building a bridge that fails, depending on your licensing, right? So you need to, if you use AI generated code, which of course you can as a tool, you need to have steps where you can convince yourself that it works, right? So on the exam, you can anticipate a question where we try to simulate that, right? Like ML, large language model spit out this code. Why do you think that's reasonable? Why can you trust that code? How would you approach that? That's all I'll say about that one. There's not much that we can say. There's a good number of exercises in here about Newton's method, okay? And so you can anticipate in the exam, same as always, that I will give you whatever formulas you need, whatever classes you're gonna need. We saw in the last exam that, some of those classes will, they may have the answer to some of the questions in the classes, right? It's really testing whether you feel comfortable enough with classes at this point where you can read them and see, maybe there's an answer hidden in some of these. Okay, so this formula up here is Newton's method. Down here, we have this class that implements it, yada, yada, yada. We went through this during that lecture, and we use this to solve a few nonlinear equations, okay? So for one exercise, right, we can check whether we can use this class, right? So for example, you may choose an equation and attempt to find a root of that equation. Okay, so for example, if you had, if you said like f is equal to x squared, x minus 2 squared, this is going to have a root, no, sorry, x squared is what I wanted. This is going to have a root at, no, sorry, I was right. If you wrote down an equation like this, you can have a root. This will give you a root when x is equal to the square root of 2. Okay, so you could put together this class, and maybe after I've run through everything, I'll see if people have a few of these problems that you want me to work through and write the code to do it. Right, but you can write a class that will provide f is equal to x squared minus 2. And we know that we should be able to recover when you plug in x is equal to the square root of 2, that f is equal to 0. Okay, so That's one example, just showing that we can design a test where we know what the correct answer should be, and then we can make the class go and reproduce that test. Okay, you can expect a question that looks like this, right? And most of my exams have one of these two formulas, right? Either I show you some code that we use during class and you would have to explain something about it. So in this case, maybe I'll show you some code that uses this Newton solver class, and you have to tell me what the function f is that that code is solving. Okay, so just like some basic comprehension. Alternatively, I can give you the function and you'll have to handwrite code using that class to solve it. The next exercise would be to make sure that you understand the derivation of Newton's method. Okay, and I've spelled it out here. Okay, the way we derive Newton's method is we want to solve for an x such that f of x is equal to 0. So what we do is we take our nth guess and we apply Taylor's theorem so that we're linearizing about our most recent guess, right? So this equation gives us, this expression gives us the equation for a line tangent to our current guess. Okay, and so with that linearized approximation, what we can do is we want to solve for when that is equal to 0. Right, so that gives us this expression. We're just substituting f of x is equal to 0. And now we can see that this gives us a formula that we can solve for xm plus 1. Okay, so that's the derivation for Newton's method, and just some basic calculus stuff. Okay, and what I really want to make sure is that you're able to sketch a few steps of that method by hand. Okay, so that way you have some sort of intuition. It's not just like Professor Trask gives you this formula and a f, and then you evaluate that formula, right? I want to make sure that you have some intuition about what it's actually doing, right? Because sometimes it works and sometimes it doesn't work, right? So you should be able to reason through, if you're in a situation where you can expect it to work or not. Okay, so I drew an example right here, right? So you should feel comfortable. Say this blue line right here is our function f of x, right? And say you can imagine a question where I say, okay, I hand you a function where f of x is x cubed minus 3x, and with an initial guess that x naught is equal to a half, right? So that's this point right here, this red circle. Take a few steps of Newton, so that way, but sketch it on the graph, right? So what I would expect you to do is identify the initial point, sketch out the tangent line to that point, right, which is this red line right here. Where that point crosses the x-axis is your next guess, right? And now you repeat. Okay, so this is our point. We're going to sketch the tangent line, right? And if you follow that to where it crosses the x-axis, it takes you here. Right, so for this one, you could imagine me asking you to reason about it. Like, okay, this problem has 3 roots. Could you suggest a different initial condition that would take you to this starred root over here? Okay, so nothing complicated. It's just you need to understand really what Newton's method is about chasing these tangent lines down towards a root. Okay, so that's all I'll say about that one for Newton's method. Okay, so going through to lecture 23, so where we started talking about automatic differentiation and gradient descent. And if people want to, you can raise your hand. You can put a question in the chat. Don't be shy. I can go through more details as needed. Okay. So moving forward to lecture 23, we talked about automatic differentiation and PyTorch and gradient descent. We introduced gradient descent which is it's a Newton's-like method where you only use first order derivatives about a function that you want to optimize. Okay, so I'd really, and especially because a lot of the exercises now that people are using AI, right? It's very easy to just kind of be like, tell me the answer, and so on. But so you can expect a lot more qualitative questions in this exam to check whether you understand like what's actually going on. Okay. So in the first exercise, we say, explain how Newton's method can be used to minimize a function, right? So in Newton's method, you plug in f, and it will tell you a x where f of x is equal to 0. Okay. So let me write this down, right? So for the usual Newton, we'll say given an f, it'll spit out an x such that f of x is equal to 0. So if we want to optimize function L, what we really want to know when L prime of x is equal to 0, right? So all we need to do is, if we wanted to make Newton's method solve an optimization problem, we could replace f with L prime. We could replace f prime with L double prime, right? And so that's the way that you could use Newton's method to minimize a function. Okay, so now you have sort of two versions of each. Let me get the stupid zoom bar out of here. All right, so now you've got two methods of each. We can say x n plus 1 is equal to xn minus L prime over L double prime. Okay. Okay, so we can see the gradient descent looks a lot like Newton's method, right? But we have this, we have the learning rate for one method where we have the second derivative in Newton's method. Okay, so you could anticipate a question that says, explain the role of alpha and 1 over f prime in both methods, right? Both of them, the gradient tells you which direction is downhill, and then both of these say how big of a step to take, right? In gradient descent, we don't feel like calculating the second order derivative, this L double prime, right? So instead, we add this parameter alpha that we have to choose, right? And so you did a lot of exercises where you ran the code. If alpha was 0.1, the code might blow up. So you set it to 0.01, and you set it to 0.001, and so on, right? So this is just an empirical thing. So you should be prepared to articulate that, right? How these relate to each other. There's also the notion of a local minimum of a function compared to a global minimum. Okay, so both of these, either Newton's method or gradient descent, they just take you to a local minimum, right? They just take you downhill until you get stuck in a little gully, but it may not take you to the bottom of the mountain. Okay, so you can imagine some questions where I'm asking you to draw some pictures and explain what it looks like, you know, like what is a local minimum, what is a global minimum, and so on. Okay, for the last exercise in this section, I say for a simple function like y is equal to x squared, draw what a single step of Newton would look like compared to a single step of gradient descent, right? And explain why each method might be preferable. Okay, so I included here code just so that way I could sketch very quickly the sort of pictures that I have in mind, right? But I might ask you to sketch these kind of pictures by hand. Okay, so if we were to minimize with gradient descent, right, it says downhill is here, and right, so here's the tangent line, right, and it will take you as far in this direction as your learning rate tells you to go, and then you stop, right? So if that learning rate's too big, you could overstep the minimum, right? If it's too small, it'll take a very long time to get to the star, to the minimum, right? And so that's what it means to dial in that alpha. For this specific problem, Newton's method would converge in one step, right? Because it's a quadratic function, and the Taylor series is going to give us, it's going to exactly capture the tangent. It's exactly going to be able to model f prime, right? Because f prime is a linear function, and we're modeling the linear function as a first order Taylor polynomial. Okay, so this sort of thing, right? This, you can imagine having to make these kind of pictures yourself, right? And so that's what you could expect as far as understanding what gradient descent is, how it relates to Newton, and so on. Okay, next I'm going to turn toward the idea about using PyTorch as a tool to automatically take derivatives, right? And what that is it lets us do black box derivatives, so we can do gradient descent on a complicated function, right? So if you specify the function, and of course we ended up using this to take derivatives of neural networks, right? Then we can minimize some loss function of a neural network, and that's what we did. Okay, so if you flip through the slides for this lecture, you could see we went through these kind of cartoons that modeled what a computational graph is, right? And how PyTorch decomposes behind the scenes a given function into a graph, and then it applies the chain rule to take derivatives, to propagate those derivatives backwards through that graph. Right, so we didn't really talk about the math, right? But you should understand that at the cartoony level, right? If you have a complicated expression, could you break it down into individual small building blocks? Okay, really what I care about though, just whether you can use PyTorch to take a derivative or not, right? So the same thing, if somebody gives you PyTorch code and it takes a backward pass, you should be able to say what it does, right? So for example, I wrote this code here. X is a torch tensor with a value of 3. And this flag says that I'm going to want to take a derivative with respect to this variable. Now it's building up the computational graph, and this is just a simple one, right? The y is equal to x squared. Now when we say y dot backward, x dot grad, or sorry, y dot grad, sorry, this is a typo, I should say x dot grad. X dot grad is going to hold the derivative of y with respect to x, right? So the derivative of y with respect to x is 2x, right? And so this should print out 6, right? Because the derivative is 2 times x, and x is equal to 3, so 2 times 3 is 6. Okay, so you got to anticipate something like that, or the other direction, right? Where I say, okay, I give you an expression like the following. You have to take a derivative of it, and you have to be able to write that down with pencil and paper. Okay. We also went through this exercise where we showed this cookbook now, right? Where we specify a model, we specify a loss function, and then we apply gradient descent to fit that model, right? So you might revisit this and just make sure that you're comfortable with all those steps and what the code is actually doing. Any questions about this? And yammering on, talking into the void for a little while. Any questions? Okay. How old were y'all during COVID? Were you guys in high school? Or were you pre-high school? Can you raise your hand if you did online lectures like this when you're in high school? Some of you. Interesting. I'm curious. I was not a professor during COVID, so this is new for me. Maybe everyone learned how to make it pop. Anyway, okay, here we are. Review lecture 24, deep learning with MLPs. Okay, so at this point, you should feel comfortable working with this cookbook, right? You specify a model, specify the thing you want to minimize, and then you hit it with gradient descent. Okay, so this lecture and the next lecture, we did that for two different kind of MLPs. We did some exercises to make sure that we were comfortable with how to do that. Okay, so you can imagine me giving you this code that I have right here. And this was taken directly from that homework or from that in-class exercise. Okay, and so here are the kind of questions you could expect. Right? I'd like you to understand what the shapes of the weights and biases are. Right, so if somebody gives you an initializer, right, like if somebody tells you input dim, hidden dim, and output dim, right, what is W1, right? So W1, this is like a matrix. That's the hidden dimension by the input dimension, right? And we talked through that in order for this to make sense, the output of one weight has to match the input of the following weight and vice versa, right? So this is just some very light. Do you understand why we had to change these things, or did you just ask Gemini what to do and it spit something out and you copied and pasted it? Okay, so it's okay if that is what you did at the time when you're doing the in-class exercise, but maybe now you can revisit it and solidify. Okay. I also might ask you to reproduce the code we did in class to add an extra hidden layer or to modify the activation function. This one uses Tanch. Maybe I ask you to use ReLU instead. Okay, so then we had this code. This was our training loop that we used to train this model, right? And and I always give you the same cookbook, right? Where you zero out the derivatives, you calculate the loss, you take the derivative of the loss right here, and then you update the parameters with a gradient. Okay, and then you step. This is just printing out some stuff at every step. Okay, so we talked about stochastic gradient descent, right? So you should be able to explain in words what stochastic gradient descent does, right? And all it does is at each step of training, you don't calculate the loss on the entire data set. You just choose a small subset of the data that you're trying to fit to, and you fit to those, right? So next step of training, you'll grab 5 points. And the next one, you'll grab 5 random different points over and over again. Okay, so what we saw was that makes the neural network train both faster and more accurately. So I'd like you to be able to explain why do we care? Why do we use that? Right, and so that I drew some pictures and we talked about that in the slides. I pointed out certain parameters in these models, right, just to force you to go back and challenge yourself and make sure you understand what individual components do. Right, so I could say, what does model forward do? And the answer to that would be, it'll take the current input data X and then push it through the neural network and spit out what the neural network predicts. Right, that would be the level of description that I'd be looking for. Could ask you what a mathematical formula for the loss that this minimizes is, right? So this would be the loss, which is something that looks like yi minus y true I squared, right? So that for this, I would be asking that you understand that this term here is the mathematical expression, right, that we're trying to take a derivative of. And then last but not least, some of the bigger problems where we did this concrete project, right, where we looked at various manufacturing parameters and saw how they impact the yield strength of concrete. Make sure that you understand what what is a regression problem, right? So I could ask you for some engineering regression problems, and you have to tell me what a regression problem is that would make sense to ask a neural network to do that. Okay, nothing more complicated than that. I just want to make sure you understand what regression is and when does it make sense to reach for this as a tool in your toolbox. Okay. Any questions about that, about MLPs or anything else? Crystal clear. Give me a thumbs up. Is this like too easy or is this what you were hoping for questions? Give me something to go on here.
Actually, I had a question.
Yep.
Should we know both the ReLU method and the other method that we learned in class?
Yeah, so what I would hope is that you can, like, in the exercise in class, we just learned that these are things that people do. Sometimes they'll do it with a Tanch, sometimes they'll do it with a ReLU. What I want to make sure that you're comfortable with is really just like making this class go, right? So if I said, okay, I don't want a Tanch, I want a ReLU, what I would be asking you to do would be just something as simple as that, right? That's what it means. And now that's a ReLU. But of course, right, like this is like an extremely accelerated introduction to all this stuff. I'm not expecting that you understand any of the machine learning or why a ReLU or why this other one, right? It's more that we understand we can optimize any function, right? So if somebody gives you a slightly different function, you know how to alter this class, right? That's the real objective. Okay. Anything else? Was good? All right, all right. So now we're on the last part. Binary classification. Okay, so, and this was the most recent one, and we didn't do it in class exercise for it. So I want to make sure that everybody spends the time going through this so they understand the broad pieces, right? You can anticipate that there will be a question on binary classification. So I just want to make sure nobody's blown it off because it was like the last thing that we learned, right? And so you should understand at a fundamental level what is binary classification and what is regression, right? So regression, you take a bunch of inputs and you predict a number, right? You're predicting a real number that's how strong is a material or what is the price my house should sell for on Zillow or whatever else. Okay. With binary classification, you're outputting a probability that something is either true or false. And so in order to do that, you take, I want to stress that you should make sure you understand what I'm about to say. You should take your ReLU network, right, which just spits out some number, like whatever number, but then you hit it with the sigmoid, and the sigmoid is this function right here that takes any number as an input, and then it maps it to something between 0 and 1. Okay, so that is how we force it, right? This is like a black box. The sigmoid turns it into a probability, okay? So make sure that you understand that you're crystal clear about that, okay? So in order to do this, we saw that it's very simple, right? There's only two small things to change. One, you go to the MLP class and you just slap this torch.sigmoid on the end, right? So we showed that that's a one-line modification to the class. So I'll make sure that you should understand that. And then the second piece is we have this different loss, right? Which we call this binary cross entropy loss, right? So in the slides, I gave some examples where we sketched out, okay, what happens when y is equal to 0, right? So if y is equal to 0, this looks like minus log of 1 minus y hat. Right? And what we saw was that gives an infinite number when it has the wrong label and 0 when it has the correct label, right? So if you push that downhill, that pushes it towards the correct classification. Okay. So make sure that you can you can explain that. You know, you understand, just like in broad strokes, you could sketch these two scenarios for this function and explain what they do. Um, then if someone gave you a model and a training loop, you should be able to identify if it's set up to do regression or classification. All right. So that just means two things, right? Is this like the y minus y data squared, or is it this y log y plus 1 minus y log 1 minus y? Right. That's the first ingredient for classification. Then you would check if it had the sigmoid, right? So that's what it means to be able to identify if a problem is set up to perform regression or classification. And then the last thing, provide an example of a sensor reading that could be provided as an input to a binary classification prediction, right? So we went through that kind of involved case about the bearing, that they did this test to say whether to do predictive maintenance to see if it was busted or not. Um, you know, a lot of us are now doing this for the final projects, right? Maybe you have a some sensor, like you have a temperature sensor, and you want it to say yes or no about whether it's below freezing, right? Those kind of like anything that takes a sensor reading and outputs a yes or a no, right? That would be an example of a binary classification problem. So I'm going to stop there. Right, that should be enough for everyone. This is good motivation to go back. If any of this wasn't clear, you can go through the slides. I'll stick around for the next 45 minutes. If you feel like you're in good shape, you're welcome to hop off. But otherwise, you can ask me questions. You can also, you can ask Gemini for answers to this. Just make sure that you understand it, right? But if you want explanations about the code, like what is a sigmoid, blah, 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 whatever you want, right? Those could be study strategies, but basically I think you should just need to step through these lectures and these slides, try to answer these questions for yourself. You're allowed to bring a cheat sheet, right? So this should be a nice, easy wrap up to the end of the semester. Right? Just check that we absorbed some of the basics about machine learning. What do you think? Any questions?
I have a question about like resources we could use
Mhm.
to kind of study these same methods. Like I know the PyTorch website has notes on like using Newton's method. Are there any other resources that would be helpful?
Do you mean for the exam
Yeah.
or
Yeah,
for?
just for the exam and like learning general uses for these like classes and different
Yes, what I'm
methods.
going to do next, what I'm going to do when we all get back from the break, I'm going to give like a goodbye package to all of y'all, which is, a list of references and for lifelong learning, or if you want to, get to know PyTorch, if you want some actual references, um, I'll give those resources to everyone. And also I'd suggest that everybody feel free to reach out to me. I've already talked to some people who are interested in this stuff about as far as preparing for the exam, my recommendation would be to not try to go through a textbook because it's going to be overwhelming, right? The stuff that I've shown here, right? As long as you understand that class, that loss function, and what gradient descent is doing, that's all you need to know, right? So there's going to be way more in a textbook. But if you want other resources, I'm happy to send me a message on Ed, and I'm happy to send you some links and stuff like that. Does that make
Okay.
sense?
Yep.
Anything else? Any other questions?
There is a probability that I might be in Princeton during that week. When will the makeup exam for this be? Is there any information
Could
on
you say that again? It's just a little bit quiet.
that? Can you hear me?
Yeah, I can hear you. It's just a little quiet.
There's a chance that I might be out of town on that week, so I was asking like when the makeup exam will be.
Yes, for everyone, if you need a makeup exam, some people actually have already taken the exam. So a lot of people have crazy travel this week and next week. So if you need any sort of accommodation, it's all good. Just send me a message on Ed and we'll find some time for you to take it. But it has to be within a week of when we actually give the exam. Was that okay? Does that work for you?
Yeah, okay, sounds good. I'll let you know.
What else? Anything else? Are there any questions? I'm happy to go through these, like some of the ones about writing code. If there's a particular question, I can answer. I can write the code myself live. It'll be a little stumbly and awkward, but I can do it.
I think in the past exams, you'd sometimes given us like some syntax to use, and then just like it was the theory that we were really being tested on. Is that like the same in this exam?
Exact same thing. Yeah. So I think I said that. Right. So if you need the formula for binary cross entropy loss, it'll be in there. If you need the syntax for how do you call the sigmoid function, I would tell you. All of these, you can plan on me giving you one of these training loops. I think it was the last lecture that I presented it like a cookbook, right? Where it was with a bunch of to-dos, right? So I would probably give you something that looks like this, right? So that way you know what the model class is. I will have clearly told you what you need to do, right? Define the parameter, initialize it, define the forward pass, yada, yada. Same thing here, right? So you get the two of these. If you need to solve something with Newton, I would give you that Newton solver class and so on, right? So like my real goal for the entire semester is that all y'all can just like run a class and write a function. You know what I mean? So, but it's not that you need to have memorized anything at all.
I have a question about the model class.
Mhm.
So for the training parameters, we were like on the in-class exercises, we were often like just changing those around, like trial by error. Will we have anything like that on the test? Because like we won't be able to see the graphs.
Yeah, I'm like really, it'll look a lot more like, which one is this? No, this is the vibe coding lecture 22. What you should anticipate is the, oh, sorry, this one, 23. Like the one where you took linear regression and you turned it into quadratic regression, right? That's the sort of thing you should have in mind. You know what I mean? Because again, right, like it's pencil and paper. You can't do like little experiments and trying out what different parameters do. I want to see that you know how to make a model. You know what I mean? Like that's the real thing I'm looking for. Right. So you could imagine, okay, I give you a model that looks like this, which is set up to do linear regression. And I say, okay, modify this so that way you could fit a quadratic polynomial. Right. So then you would know, okay, well, all I need to do is boop, 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 this plus self.c times x squared. Right, that's the level, right? That you should feel confident that you could fit any model that you want, right? For any sort of expression in here. What else? What else? Any other questions? Going once, going twice. Everyone's all good. Any questions about the final project? So have you all been able to get a, does anyone not have their stuff? Who's got their stuff? It's all
How
right.
do we check again if we have our materials?
At this point, everything, I can pull it up right now. So this is the ordering form. Sorry, let me get it on the Excel spreadsheet, not in the. Oh, there were a lot more green ones here before. After this, I'll send I have to hunt it down. I think the guy who's been maintaining the inventory changed the place that he was storing it. But basically we have a list, and it'll be green if your stuff has come in. So you just need to go, if you're on campus, you can just go to it's Peter Bruno. His office is one door to the right of the GM lab. So it's like in between the 3D printing room and the GM lab. And he has all the stuff there, and he'll give you a Pico. He'll give you whatever you need. If you've already left for Thanksgiving break, don't stress about it. You could just pop by that Monday once we get back, and he should have stuff. Should have your stuff waiting. Any other questions, or is everybody all good? All right. Well, happy Thanksgiving, everyone. And if you have any questions, just reach out. I'm happy to have one-on-one Zoom meetings or whatever people need over the course of the next week. Okay. Take care.